Hybridization. What is hybridization? To answer this question, you first have to know what orbitals are. Orbitals are the mathematical expression called a wave function that describes properties, characteristics of no more than two electrons in the vicinity of an atomic nucleus or of a system of nuclei as in a molecule. So basically, it represents the amount of electrons located in an area, and this amount of electrons determines the amount of bonds the atom is capable of having. To represent this, boxes are used. Each box is able to hold two arrows, one going up and one going down. The direction of these arrows represents the spin of an electron. Each electron spins in the opposite direction of the partner. Each electron is represented by one arrow, and the boxes are filled from left to right. An important thing to keep in mind is that only one arrow is placed in a box at one time. No one box can have two arrows until all boxes currently have one. However, this does not always represent the amount of bonds an atom is able to make. This is where hybridization comes into play. Hybrid orbitals occurs when one orbital mixes with another and forms a hybrid of two original orbitals. This allows for an accurate representation of the amount of bonds an atom is capable of forming. Pi bonds and sigma bonds. 3.14. Perhaps the most American, non-American dessert is also a type of bond that atom forms. There are two types of bonds. There are pi bonds and sigma bonds. These are easy to understand. The first bond is formed by an atom is a sigma bond, and everything after is a pi bond. So, as an example, carbon is capable of forming four bonds. First, it forms a sigma bond, and then it forms a pi bond. Differences between electron domain geometry and molecular geometry. Electron domain geometry and molecular geometry. Electron domain geometry is a three-dimensional arrangement of electron domains around the central atom of a molecule, whereas molecular geometry is the arrangement of only the atoms in the molecule. So for example, nitrate forms an electron domain geometry called trigonal planar, while it has a molecular geometry known as bent.
Alright guys, time for a little switch. So now we're going to be talking about electron domain geometry and then molecular geometry. Electron domain geometry is a three-dimensional arrangement of electron domains around the central atom of said molecule, while molecular geometry is a simpler arrangement of only the atoms and the molecule. We're also going to be discussing the number of electron domains, which is subdivided into bonding domains and non-bonding domains. So first, we're going to be talking about trigonal planar. Trigonal planar has three domains. In this first example, we will have 3 bonding domains and 0 non-bonding domains. And as shown in the molecular geometry, there's going to be one central atom, in this case boron, with 3 fluorine atoms surrounding. In the second example, we will be using nitrogen dioxide. As shown in the drawing, only 2 of the domains are filled, while one of them remains unbonded. This unbonded domain allows for the free electrons to, well, flow freely. Next, we will be moving on to the linear geometry. In this case, there are only 2 electron domains. So now it's time to move on to octahedrals. And as you'll see soon, in just a moment, let me work on it, will be the planar field that I'm going to be using.
Octahedrals. Each one has at least 6 electron domains, 6 bonding and 0 non-bonding.
So, while we wait for my drawing, how about you confess?
I'm sorry, your slow drawing needs to hurry up.
Well, your confession needs to hurry up.
Well, there's no such confession from me.
You sure?
I'm pretty sure.
You sure about that?
Yes. Only Josh's love for Tagam.
Is ortho a line?
It's a 1. It's a 1.
Julio, please.
But you're gonna confess to her soon, right?
I have no idea what you're talking about. Can you draw and hurry up, please? I know you're so slow. I just want to play Bloodborne. By the way, that's the game we just got while we weren't working. It was a noob's idea. Tagami, lower his score, please. Please, for me. Please. Alright, so now we are on square pyramidal. We have 5 bonding domains and 1 non-bonding domain. What a loner, just like a noob.
It's all over now.
Okay, it's all over now.
For you.
I don't know how to respond to that.
Cry. I would.
Moving on.
We're going to the square planner with 4 bonding domains and 2 non-bonding domains.
Talking a little faster, huh?
Why? Why me? You should be talking. You only have 2 friends now.
It's okay, I never need you anyways.
We have Josh and Julio, it's okay.
That's all I need. They have my love. You don't.
I don't need your love. I have Bloodborne. You're Bloodborne.
At my house.
He just. Hey, Darian, shut up. You were Bloodborne.
I am Bloodborne. That's okay with me.
No, you were born. You were Bloodborne.
What's he LMH?
I'm talking about like when he was born. Like the doctor's like, "Oh God, so much blood."
This is being recorded, you know.
Wait, what's
Wait, this is being recorded?
Yes!
Yeah.
Oh.
What do you think I'm talking back at him?
Darian, I'm sorry for telling the whole world the truth.
Sorry that
That
you
he
love.
likes you?
I don't know what you're talking about.
Well, yeah, so when's your confession gonna happen?
I have no idea what you're talking about.
He confessed into
We're
the
cutting
cherry
this part
blossoms in
Because
November.
we're trying to make Tagami think that, trying to figure out who I like, right? Just about that. We'll cut off like that. So he'll be actually watching through the video. So we should be cutting off right now.
Alright.
There we go.
So now it's time to move on to octahedrals. And as you'll see soon, in just a moment, let me work on it, will be the planar field that I'm going to be using.
Octahedrals. Each one has at least 6 electron domains.
7 years ago, our forefathers taught us how to figure out the bond angle formed in this molecule. The first thing to do to figure this out is to count the number of valence electrons each of the atoms in the molecules have, and add them. Then the first atom is placed in the middle of the Lewis dot diagram, and the rest of the atoms are placed around it. A bond is represented by a line going from the middle atom to the other. This represents 2 electrons. Each atom should have a complete octet unless it is hydrogen, which only requires 2 electrons. The total number of electrons that were counted shall be present in the Lewis dot diagram.
For example, sulfur fluoride, SF4, has 34 electrons, 6 from the sulfur and 7 from each fluoride. The sulfur atom is placed in the middle of the Lewis structure, and the fluorides are placed around it. One line is drawn from the sulfur to each of the fluorides, and then 6 dots are placed around each fluoride. These are counted, and what you notice is that there are only 32 electrons present. Because of this, an electron pair is drawn on the side of the sulfur, changing the angle of the bonds. Fuck that one too. In the second example, we will be using nitrogen. Oh.
No, because now I'm gonna punch. I will twist and pull that shit.
I have nothing to
Can you draw it this
You have to
time?
lose your
Can I draw
nuts.
it? Yeah.
After I get yours.
That's not a problem.
Oh, that's a
Dang, you're already afraid of me. You're not gonna do it.
Are you sure?
Yeah, I'm sure.
You think I'm gonna do it?
I don't know.
What happened?
You don't look like you're gonna do it.
Darian, I'm telling
I'm
you.
gonna do it.
Do you want me to have your
I'll,
kids
go high, I'll even go higher, dude.
go as high as you want because you're gonna drop it?
You just did.
Okay.
You ain't gonna drop it.
You
You ain't gonna, because if it hurts.
You think I'm gonna drop it?
No, see,
If
the
it's
bad
hot-
thing is that he's gonna like it.
Yeah, you know what, Darian? I'm gonna tell you this right now. If it does, here's the best thing. It landed like my tip was like whoop.
Oh shit, we're still recording this.
You think I'm scared?
You think I'm I got nothing.
What are we gonna do with this video?
You're fighting something
We're
that
gonna,
wants
we're
you to
gonna
touch it.
put it up online, of course.
Do we want to put this in the bloopers reel? I mean, in
Oh, I did YouTube, but
Smell dick.